When I first heard about structural insulated panels in 2001, I wasn't impressed. And why would I be? How could slabs of foam and sheets of OSB or plywood really replace studs and rafters in a house frame? It didn't seem reasonable, but despite my initial skepticism, I did take a closer look. And the more I discovered about the strength, efficiency, and ease of working with structural insulated panels, the more I became convinced they're a good idea. That conviction became a reality for me in 2003 when I used structural insulated panels, also called SIPs, for the workshop I'm in right now. After that hands-on building experience and the chance to monitor energy performance, I felt confident enough to recommend SIPs construction to friends and clients, while also overseeing the construction of 2 SIPs-based homes. I'm convinced that SIPs are an excellent way to build, and there are specific reasons why I've come to this conclusion. All SIPs have a foam core, flanked with oriented strand board or plywood glued to both faces in the factory. Panels come 4 feet wide and in lengths varying from 4 to 16 feet and more. Panel thickness varies from 4.5 to 12.25 inches, delivering insulation values from R19 to R57. But these numbers alone don't tell the whole story. Since the insulation of SIPs is continuous and unbroken by studs, real-world energy performance is more impressive than the numbers alone would lead you to believe. All else being equal, a SIP home uses roughly half the energy for heating and cooling than a comparable code-built, stick-framed, bat-insulated house does. Part of this benefit also comes from the fact that it's much easier to build an airtight home using SIPs than studs. Air infiltration measurements taken on more than 8,000 wood frame homes built between 2000 and 2008 showed that more than half leaked more air than is currently considered acceptable for new houses. SIP homes, on the other hand, routinely have air leakage rates 70% lower than the toughest Canadian building requirements. SIP structures are also proven to be about 3 times stronger than stick-built equivalents, while adding less than 5% to total building cost. Since SIPs replace both conventional wooden framing and traditional insulation, they're quick to go up. The foam is recessed along the bottom edges of the panel, allowing them to interlock with 1.5-inch thick bottom plates. Recesses along the sides accept foam and OSB splines for connecting neighboring panels. The top of each wall is capped with 1.5-inch thick lumber and a cap plate to finish things off. The inside edges of door and window frames are also lined with solid wood in the same way. There are 2 different kinds of SIPs in the world: standard rectangular panels that you cut to fit on site, and factory-cut panel packages. I prefer site-cut panels because they're available more quickly, it's simpler to keep them organized during construction, and it's easier to create a gap-free structure when you can cut panels to fit specific situations. Expanding foam sealant is applied to all joints in SIP construction immediately before assembly. And this continuous air barrier is one reason why air leakage rates are so low. A tool called a hot knife lets you re-establish recessed edges on site-cut panels, and a Prezi beam cutter is my favorite tool for cutting panels to length, width, and angles. SIPs can also be used for vaulted ceilings, replacing the need for joists. The easiest way to install electrical wiring through SIPs is by running the cables horizontally through floor and ceiling joists, then running them down or up through site-cut vertical chases in the panel skin. Let the foam harden, slice it off, and you're ready to apply your interior wall finishes. Building codes across Canadian provinces are requiring better energy performance, and SIB panels offer the easiest way I know of to meet these rising expectations. They're easy to work with, strong, and yield energy-efficient structures. What more could anyone want?